Hi dear student, here is another video on project ideas for art integrated project. This is our fourth video on project ideas. You can find the link of our previously uploaded videos in our description box. In this video, we will be discussing some more project ideas in the subject Maths and Science. Ever since our previous videos were uploaded, we had a lot of requests for new project ideas on our subjects. We believe our subject experts have answered almost all your queries. Since we are not able to handle all the requests in one video, we plan to make two videos, one on math and science and another on social science and languages. In this video, we will be discussing some of your project requests in mathematics and science which we think will benefit others also. So let's begin. Welcome to the video. This video is brought to you by our new platform R Science. In this playlist, we will be uploading videos which will promote scientific thinking among young minds. We plan to make videos on general science topics, science lectures, and contemporary science debates. Please let us know if you have any suggestions. This video consists of mathematics projects such as finding the surface area and volume of buildings, applications of arithmetic progression and Pythagoras theorem, and similar geometric shapes. There will be project ideas for lower grade mathematics, projects including histograms, pie charts, and bar graph, etc. The science project we discuss in this video includes science of musical instruments, skydiving, and soil chemistry. Surface area and volume. Every building you see around you is made of several mathematical objects. The total surface area or volume will be the sum of individual surface areas and total volume will be the sum of individual volumes. Finding the area and volume of a building includes dividing the structure into geometrical shapes, finding the area or volume of individual shapes, and then adding it. Consider this picture of Taj Mahal. Divide the picture into several cells and scale it into suitable unit. This picture reveals that the Taj Mahal consists of geometrical shapes such as spherical caps, cuboids, cylinders, etc. A spherical cap is a portion of a sphere. Therefore, its area can be calculated as area of a complete sphere minus area of the removed portion. Similarly, volume can be found as volume of a complete sphere minus volume of the removed portion. A cuboid has 6 faces, with opposite faces having similar areas. Therefore, surface area of a cuboid is the sum of areas of its 6 faces. Here in this picture, you need to consider only the areas of the exposed portions. The volume of a cuboid is given as the product of its length, breadth, and height. The surface area of a cylinder is the sum of its total surface area and the area of the top and bottom circles. In this picture, you need to consider only the lateral surface area, which is equal to 2 pi r h. The volume of the cylinder is given by base area pi r square times the height h. Consider another example. The given picture is a famous temple in Himachal Pradesh. You can see that the structure consists of trapezoids, cones, and cuboids. The area of lateral surface area of a trapezium is given by A equal to half A plus B into H, where A and B are top and bottom length of the trapezium. Therefore, the total surface area can be calculated as the sum of area of 4 trapezium and the base area. The volume is given by the base area, that is half A plus B into H times the height L. The lateral surface area of a cone is given by pi LR, where L is the slanting height. Therefore, its total surface area will be pi r square plus pi LR. The volume of a cone is given by 1 by 3 pi r squared H. During the calculation of surface area, make sure that you consider only the portions which are exposed. The hidden portion of the geometrical shape should be ignored. Now, let us look into the project ideas on arithmetic progression. Arithmetic progression is a sequence of numbers with a common difference. This mathematical technique can be found in ancient Indian architecture. Consider these two temples. Here you can see either a recurring addition of a structure or addition of a length. Let D be the additional length or the number of additional elements. Then the number of elements in the nth row or the length of the nth step can be found using the formula An is equal to A1 plus n minus 1 into D, where A1 is the length of the initial step or number of elements in the initial step. The total number of elements up to the step n or total distance up to the step n can be found using the equation Sn is equal to n by 2 into 2a1 plus n minus 1 into d. While working on arithmetic progression in architecture, make sure that you do not confuse arithmetic progression with fractals. Fractals are same structures repeating in smaller scales, while arithmetic progression is the addition or subtraction of an element with the same dimension. Now let us discuss a project using Pythagoras theorem. The Pythagoras theorem can be used to find the linear distances between any two points in a map. Find a map with scale marked precisely. To find the linear distance between any two places, draw a line connecting these points. Construct a right-angled triangle. Measure the horizontal distance b and the vertical distance a. The distance d can be found using Pythagoras theorem as d is equal to root over a squared plus b squared. Now let us discuss some ideas using pie charts, bar graph and histograms. This project is ideal for lower grade students. Primary school students can also try this project under the guidance of a teacher. A pie chart is used for pictorial representation of a data which is given in percentage. Whole circle represent 100%, half circle represent 50%, a quarter circle represent 25%, and so on. Given is an analysis of religious diversity in the states Kerala and Himachal Pradesh. The number denotes percentage of people believing in each religion. This analysis can be represented using a pie chart as shown. A pie chart enables us to understand the quantity of a data in comparison with others. A bar graph is also a method for pictorial representation of data. This is used when actual numbers is to be compared and not the percentage or relative quantity. Given is the data of percentage of GDP from primary, secondary and tertiary sectors in Kerala and Himachal Pradesh. This data can be represented using a bar graph as shown. This data can also be represented in pie charts also. Histogram is a bar graph or a line graph used to represent frequency distribution or change rate of a variable. This data is the production of rice in Kerala in lakh tons over 6 decades. This variation can be plotted using a bar graph as shown. The same data can be plotted using a line graph also. Now let us study some musical instruments in Himachal Pradesh and Kerala and the science behind them. Rich cultural heritage of Kerala and Himachal Pradesh has provided both the states with its own authentic music and musical instruments. Both the state has string instruments such as Sarangi and Veena, wind instruments such as Shehnai and Kurunkural, and drum instruments such as Naghara and Chenda. Sound is a form of energy which is propagated as vibrations through space. All musical instruments are designed to produce vibrations of different frequencies and intensities which when played harmonically will produce music. Consider the drum instrument Naghara. It has a hollow chamber covered with a skin. The skin of the drum vibrates when it's stuck by a stick. The air molecules vibrate against each other and makes the sound waves. This sound propagates as pressure waves through air and the sound of the drum can be heard. The pitch of the drum depends on how tight its skin is. If the skin is tight, then the drum makes a high note. If it is slack, it makes a low note. The amount of air inside a drum also influences its pitch. More air in a drum results in a lower note. Less air in a drum produces a high note. Volume depends on the size of the vibrations that are made. When we hit a drum hard, it makes big vibrations and a loud sound. Hit a drum softly and the vibrations are smaller and the sound is low. Now let us learn the science behind string instruments using Sarangi. Every string instrument has strings of different thickness tied in different tensions to produce vibrations of different frequencies. Strings are attached to a hollow air chamber which helps in amplifying the vibrations. The shape of the chamber, material of the string, and the vibrating pattern is different in different instruments and thus they sound different. Sarangi is a bowed string instrument, like violin. A bow is brought in contact with the string in a stick-slip manner to produce vibrations. On the other hand, veena or a guitar is a plucked string instrument. There are struck string instruments like piano also. The strings are closed at both ends and they make harmonic vibrations with odd and even multiples of resonant wavelengths. Pitch can be adjusted by varying the length of a string. A longer string results in a lower pitch while a shorter string results in a higher pitch. The frequency is inversely proportional to the length. A string twice as long produces a note of half the frequency, that is an octave lower. Pitch can be adjusted by varying the tension of the string also. A string with a less tension, that is a looser string, results in a lower pitch, while the string with a greater tension, that is a tighter string, results in a higher pitch. The frequency is proportional to the square root of the tension. The pitch of the string can also be varied by changing the linear mass density, that is mass per unit length of the string. A string with a higher mass density produces a lower note. In practical applications such as double brass string or brass piano strings, extra weight is added to the string by winding them with a metal. A string with a heavier metal winding produces a lower pitch than the string with equal length without a metal winding. The frequency is inversely proportional to the square root of the linear mass density. Now let us learn the sound production in all wind instruments. Wind instruments such as Shehnai is a resonance tube with one end open. The sound produced depends on the entry of air into the flow control valve or reed, which is attached to a resonant chamber or a resonator. The resonator is typically a long cylindrical or conical tube, open at the far end. A pulse of high pressure from the valve will travel down the tube at the speed of sound. It is reflected from the open end as a return pulse of lower pressure. Under suitable conditions, the valve will reflect back the pulse with an increased energy until a standing wave forms in the tube. Standing wave inside the tube will be odd multiples of quarter wavelength with an anti-pressure node at the mouthpiece and a pressure node at the open end. The reed vibrates at the rate determined by the resonator. The holes in the resonator determines the pitch of the sound. We had a lot of requests for science projects, so here is one more. Let's learn the physics behind skydiving. Skydiving is a tourism activity in many parts of India. So, this project can be clubbed with tourism activities, economics, etc. as per your choice. Skydiving is a fun ride with gravity and buoyancy. The concepts used in this project includes gravitational potential energy, air drag, terminal velocity of a fluid, work energy theorem, and some aerodynamics. In skydiving, a diver jumps off from a helicopter or an aircraft, glides through the air, and finally reaches the ground with the help of a parachute. When a person jumps off from an aircraft, the gravitational potential energy will accelerate her towards the ground with an acceleration equal to 9.8 meter per second squared. In vacuum, all particles will fall at the same rate, but in air, the fall rate is affected by the surface area and mass of the body. During the fall, the air molecules will constantly collide with the falling body and the body will reach a terminal velocity. Terminal velocity is the maximum velocity attainable by an object when it falls through a fluid. It occurs when the sum of the drag force and buoyancy is equal to the downward force of gravity acting on the object. Since the net force on the object is zero, the object has zero acceleration. The terminal velocity of each diver differs with their mass and area of exposure. It is given by root over 2mg by rho ACD, where m is the mass, rho is the density of air, CD is a drag constant, and A is the area of the falling body. During skydiving, the skydivers take many tracking positions which varies the air drag they experience. A delta track is used to track in one particular direction. In this position, the body is held tight in a straight line position and the diver moves in the direction of her head. In a flat track, the diver spreads her legs at the shoulder level with pointed toes. This will provide her with a horizontal velocity. This position is used when the diver has to move away from a group. The iron cross track is used for a lightweight free fall. The stretched hands improves the surface exposed to the air and the air drag slows down the rate of fall. On reaching a specific height, a parachute is deployed to reduce the vertical velocity. A parachute is designed to have a very large surface area that will increase the air drag and reduces the rate of fall. On deploying, the diver is pulled up until the gravity and buoyancy matches, and after that, the diver falls at a constant rate. This will enable a safe landing. Now, let us learn the soil types found in Kerala and Himachal Pradesh and their chemical components. The soil found in Himalayas are diverse in character depending upon the altitude, vegetation cover, slope, structure and stage. The major soil groups in Himachal Pradesh includes brown hill soil, submountain soil, mountain meadow soil and red loamy soil. Most of the soil is acidic in nature. Acidic soils are profoundly seen in high altitude regions. The Himalayan foothill or terrace soil has a high content of organic matter and nitrogenous compounds. They lack phosphorus. It is transported by hilly rivers and streams. This soil is acidic and is poor in plant nutrient. It is made of sandy material and raw humus. The forest soil is formed under high acidic conditions or mildly acidic conditions under forest. The acidic humus provides it with an acidic nature. The topsoil is rich in humic matter. Organic debris from dense canopy contributes to the top humus of the soil. The pot soils is infertile acidic soil developed under coniferous forest in humid temperate conditions where rate of precipitation exceeds the rate of evaporation. Continuous percolation of water causes leaching of minerals like iron and alumina from the upper layers, resulting in the formation of a grey bleached zone on the upper surface. This soil lacks nutrients and is acidic in nature. Hence, they have a poor agricultural productivity. The percolated minerals often form an impermeable layer at the lower end of the soil profile, which restrict the water drainage. These soils occur in high altitude areas near snowline areas. The parent rock with develops varies of quartzites to granite, schist and gneissic rocks. The red and black soil is formed from acid and base igneous rocks like granite. Red soil is lime deficient, carbonate free and light textured. Black soil is very less clayey, lime deficient. It is also deficient in phosphate, nitrogen, lime, and humus. The desert soil or arid soil is found in cold desert areas. It is sandy to loamy texture with clayey content less than 15%. It is pale brown to yellowish brown in color. It is infertile and is lacking nutrients like nitrogen, phosphorus, potassium, sulfur, and zinc. Mountain or hill soil is found in very high altitude areas under subtropical and temperate conditions. It is very thin, fertile, and less than a centimeter deep in steep slopes. It is mixed with pebbles and gravel in many regions. Texture varies from sandy to loamy. Reaction varies from acidic to neutral, and organic matter content in these soils ranges from 1 to 5%. The high altitude meadow soils are found in the areas of negligible rainfall, and the main form of precipitation is snow. It is thin and fragile soil. Its texture is coarse with high gravel content. It is dark in color and has a high content of humus. Himachal Pradesh also has traces of alluvial soils also. The major soil type in Kerala is alluvial soil and black soil. The coastal alluvium soil. These soil of marine origin are identified along the coastal plains and basin lands as a narrow strip. The soil of the coastal plains are very deep with sandy texture. The texture generally ranges from sand to loamy sand with grayish brown to reddish brown and yellowish red in color. Sand content ranges from 80% and clay up to 15%. Even though these soils have high water table, the water holding capacity is poor due to predominance of sand. Coconut is a major crop in this area. Cashew and other fruit trees are also grown. The mixed alluvium is mainly noticed close to coastal alluvium. The soil are frequently flooded and submerged. The groundwater table of these soils is generally high and it reaches above the surface during rainy season. It has a texture of sand clay loam to clay. Light grey to very dark brown is a common color of the soil. Paddy, other annuals and seasonal crops like banana, tapioca and vegetables are grown here. Acid saline soils are present throughout the coastal areas in patches. The area under these soils comprises of very low-lying marshes, waterlogged and ill-drained areas near the rivers and streams. Sea and backwater tides make these soils saline. During monsoon season, when the rainwater and fresh water from the rivers enters the field, salinity is partially washed off. The area under these soils occur mostly on plains at or below sea level. A wide variation of texture from sandy loam to clay is noticed with dark grey to black color. Paddy is the only crop that can be cultivated in this region. Laterite soil is a weathering product of soil which is several causes of weathering and mineral transformations takes place. It involves removal of bases and substantial loss of combined silica of primary minerals. The area comprises of mounds and low hills with gentle to steep slopes. Laterite soils are generally suitable for most of the dryland crops. It is mainly cultivated with coconut, arecanut, banana, tapioca, vegetables, yams, pepper, pineapple, fruit trees, etc. The percentage of gravel content in the soil is reduced to soil depth limits of the choice of crops. In laterite outcropped area with shallow soils, only cashew can be grown with vegetables. Black cotton soil. These soils are identified in alluvial plains. These soils are very deep, black and calcareous. The texture of these soils ranges from clay loam to clay. They possess high string swell capacity and hence exhibit the characteristic cracking during dry periods. A variety of crops such as coconut, sugarcane, cotton, chili, pulses and vegetables are grown here. Red soil. These are found mostly along the foot slopes of laterite hills and mounds. These are mostly very deep and homogeneous in nature. The texture of the soil generally ranges from sandy clay loam to clay loam with red to dark red in color. Gravels are rarely noticed in these soils. A variety of crops such as coconut, arecanut, banana, yams, pineapple, vegetables, fruit trees, etc. can be grown under proper management. Hill soils. They are found in regions which has a general slope ranging above 10%. The texture of these soils generally range from loam to clay loam with average gravel content of 10 to 50%. In addition, stones are noticed in the subsoil. These soils have reddish brown to yellowish red, strong brown color. Generally, increase in clay content is noticed down the profile. In the depth of the soil varies considerably from 60 to 200 cm depending on the lie of the land, erodibility of the soil and past erosion. The area is suitable for dryland crops like rubber, coconut, arecanut and fruit trees based on the topography. Crops such as banana, pepper, pineapple, vegetables can be grown in the foot slopes. Forest soil. These soils are developed from crystalline rock of Archean age under forest cover. They occur along the eastern part of the state, generally above the elevation of 300 meters above mean sea level. The depth of the soil varies considerably on erosion and vegetative cover. The soil are generally immature due to low weathering process. Rock outcrops and stones are noticed on the surface. The texture of the soil ranges from sandy clay loam to clay with reddish brown to very dark brown color. Forest trees, shrubs and grasses are grown here. Hope you have all enjoyed the video on project ideas on mathematics and science. Please notice that any of these projects can be combined with a language project. You can present any of these studies in the form of a brochure, documentary, article, etc. to make a good language project. We will be uploading a brochure making tutorial using Microsoft PowerPoint soon. Please go through the references for more details. Thank you for watching this video. For more such informative videos, please subscribe to our channel.